So in 4.2, we're going to be talking about properties of parallelograms. So a parallelogram has two sets of parallel sides. You can see it's denoted here that these two sides are parallel with these arrows. So note how there's two arrows on those, and then these two sides are parallel based on the one arrows, the single arrows. So if a quadrilateral is a parallelogram, then opposite legs are congruent. So you can see here that this leg is congruent to this leg, and then these two legs are congruent. If both pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. So that's just going vice versa. So if a quadrilateral is a parallelogram, then opposite legs are congruent. And if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So the converse is true. Also note, still on parallelograms, that if a quadrilateral is a parallelogram, then opposite angles are congruent. And that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So a lot of congruent going on here. So that's just saying that angle J and angle L are opposite and those are congruent. And angle M and angle K are opposite and those are congruent. So therefore it's a parallelogram. And then if a quadrilateral is a parallelogram, then consecutive angles are supplementary. So you should be noticing a lot of things back to Unit 2. So this is saying that consecutive angles, so like J and M, those are supplementary, so therefore they add to 180. So think back to Unit 2. We know that these lines are parallel. And then here would be our transversal. So this is like saying consecutive interior angles are congruent. So this is just tying all of that together. So example number 1, find the values of x and y so that the figure is a parallelogram. So if it's a parallelogram, we know that these two sides are congruent. So we can say opposite sides are congruent. So we can set 6x plus 3 equal to 15. Solving, we get 6x equal to 12. So we get x equals 2. Plugging that in, we know that these sides are also congruent. So we know 4x minus 2y equals 2. But we know that x equals 2. So we get 4 times 2 minus 2y equals 2. 8 minus 2y equals 2. Subtracting over, we get negative 2y equals negative 6. So we get y equals 3. So note we just set opposite sides equal to each other since they are congruent. And then find the values of x and y so that the figure is a parallelogram. We also know that opposite angles are congruent. So we can set y plus 10 equal to 2y minus 40. Solving for that, we'll add our 40 over and we'll get y to be 50. So that's going to make this angle 50 plus 10. So this angle is going to be 60 degrees. And note, previously we said that consecutive interior angles, the consecutive angles of a parallelogram, have to be supplementary. So angle B and angle A have to add to be 90 degrees. So we can get 60 plus 4x has to equal 90. So we're going to get 4x, sorry, supplementary. Supplementary, they have to add to be 180. So we get 4x is equal to 120. So we get x to be 30. So note that's just using the properties of parallelograms that we learned on the previous page. Moving on to our next quadrilateral, or the next properties, we're going to say if a quadrilateral is a parallelogram, then the diagonals bisect each other. So bisect, that's saying that these two sides right here are congruent, and then that these sides right here are congruent. So just note that bisect means that the diagonals on both sides are congruent. So also the converse is true. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So find the values of x and y for the figure to be a parallelogram. So we can see we want these two sides to be congruent and then these two to be congruent. So we can set negative 4x minus 2 equal to the other side, which is negative 3x plus 4. Solving, we can add our 4x over and subtract our 4 over, so we'd get negative 6 equals x. Looking at our other ones, these pair, we're going to set 2y plus 8 equal to 3y minus 5. So we're going to add our 5 over and subtract our 2y over. We get 13 to be our y value. So note, that's just saying that bisecting sets the two equal to each other. So combining all of these properties and everything we know, we're going to find the values of x, y, and z. So solving first for x, we know that opposite sides have to be congruent. So we can say that 5x equals 27. So we get x to be 27 over 5, or also 5.4. So that is our x value. Solving for y, we can see that we have this length and this length. So we have 2y minus 5 and y plus 4. So we're going to set those equal to each other because they're the diagonals and they bisect each other. So 2y minus 5 equals y plus 4. Solving, we will get y to be 9 by adding our 5 over and subtracting our y. And then also note here that we have solving for z. Note that these are parallel. And then we have a transversal here. And so we want solving for z in this one and this one. So what do we have? We have alternate interior angles. And alternate interior angles are congruent. So we can set 3z equal to 33 degrees. And then divide by 3 to get z to be 11. So theorem 6.12, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So that's saying that since AB is parallel to DC and it's also congruent, since these two are parallel and congruent, then it must be a parallelogram. So this is kind of think back to some of the proofs we were looking at. This is a theorem now that we can use. So using properties of parallelograms, do we have enough information to conclude the following are parallelograms? So 5, think back to the first page. We have that opposite sides are congruent, and so that's a yes. Here, we have the opposite sides are congruent, and that each of these angles is congruent, but together, that was not enough information. And then 7, we have parallel sides and they're congruent. So that's back to our theorem 6.12 at the top of the page. And so that is yes. Then here we have that they're congruent but not necessarily parallel. So that is not enough information. So no. Number 8 does not give us necessarily a parallelogram. So looking at coordinate geometry, it says graph quadrilateral QRST with vertices at these coordinate points and then determine whether the quadrilateral is a parallelogram. So justify your answers by using the slope formula. So we're going to find the slope for each of these. So for QR, we're going to take 1 minus 3, so our y values, and then subtract our x values. We're going to get a slope of negative 1/2. Carrying that out for the rest, slope of ST is negative 1/2. The slope of RS is 4. And the slope of TQ is 4. So, is this a parallelogram? Yes, this is a parallelogram because opposite sides have the same slopes, so therefore opposite sides are parallel, which was one of our theorems or conjectures that we could conclude. Parallelogram. Thank you for listening, and good luck on the practice.